Hey there, map enthusiasts. Ever feel like the world of geography is full of these little mysteries, like we just accept them? Well, today we're diving deep into your Term 1 geography notes, and trust me, we're about to unravel some of those head-scratching concepts, about maps and globes and the wild world of time zones.
It's funny, isn't it? We use maps every single day on our phones and our cars,
Right.
but we rarely stop to think about what actually goes into creating them. These visual representations of our planet, it's fascinating.
So true. And one of the first things I noticed in these notes, it's all about map scales. We've got world maps, regional maps, even local maps. What is the deal with all these different scales? They're all showing the same Earth, right?
Right, but it all comes down to the level of detail. It's about the mathematical relationship between the map and the actual area it represents. Imagine comparing a map of your country to a street map of your neighborhood. The neighborhood map needs to be way more detailed to be useful, so the scale has to be much larger. That's the key here. Scale shows us how much smaller a map is compared to the actual size of what it's representing.
So like when I zoom in on Google Maps, the scale is changing to show me more detail.
Exactly. As you zoom in, the scale increases, showing more details, like streets and buildings. Zoom out, and the scale decreases, giving you a wider view, but with less detail. Think of it like shifting your perspective. Sometimes you need to see the whole forest, and sometimes you need to focus on a single tree.
I like that. That's a great way to put it. And it makes me wonder if there are so many different scales for maps, are there also different ways to even like project the Earth, onto a flat surface? Because I mean, the Earth is a sphere, right?
You're spot on. That's where map projections come in. It's literally impossible to flatten a sphere perfectly onto a flat surface, not without some distortion, anyway. Different map projections try to minimize these distortions in different ways, but there's no one perfect projection. Some projections preserve area accurately, while others prioritize accurate shapes or distances.
Wow, so every map we look at is kind of a compromise. It makes you realize how much we rely on these imperfect representations to navigate and even just understand the world.
Precisely. And understanding these limitations helps us interpret maps more critically.
Okay, so we've tackled scales and projections. But there's another mind-boggling concept in these notes, the Earth's rotation. I mean, we learn about it in school, sure, but have you ever really stopped to think about it? Like, we're spinning through space right now.
It's truly amazing when you stop to consider it. And you're right, we rarely feel it in our daily lives. This is because of the Earth's massive size and its constant rotational speed. We don't sense the movement because everything around us is moving at the same speed.
That it's all relative. That actually reminds me of something you mentioned earlier about how even though the Earth is a sphere, we still represent it on these flat maps. Is there a way to actually visualize something like longitude on a round object, like on a globe?
Absolutely. Imagine taking an orange and slicing it from top to bottom. You'll create segments that all meet at the poles, right? Well, on Earth, these imaginary lines running from North Pole to South Pole, those are called lines of longitude. Each segment represents a degree of longitude.
Okay, I think I'm starting to picture it. But what do these lines of longitude actually have to do with time zones? My notes mention them together, but I'm a little fuzzy on the connection, to be honest.
That's a great question. And it leads us right into the heart of how time zones work. You see, the Earth rotates 360 degrees in a day, right? Which means it rotates 15 degrees every hour. Each of these 15-degree segments corresponds roughly to a time zone. The prime meridian, which runs through Greenwich, England, is our starting point. That's 0 degrees longitude.
So as we move east or west of the prime meridian, we're essentially moving through these 15-degree segments, and that's why the time changes.
Exactly. Now, it does get a bit more complicated than that because governments sometimes adjust time zones, to better suit their country's needs and borders.
Right, so it's not always as easy as moving 15 degrees and like changing the time by an hour. My notes mentioned something about the international dateline. What even happens there?
The international dateline. I like to think of it as the place where today meets tomorrow. It's an imaginary line, mostly following that 180-degree meridian, so opposite the prime meridian. As you cross this line traveling westward, you add a day to your calendar. And if you're traveling eastward, you subtract a day.
Wow, it's like time travel, but with extra paperwork, right? So if I'm understanding this right, someone could, like, theoretically celebrate their birthday twice by just hopping back and forth across the date line.
Well, in theory, yeah, I guess so. It really just highlights how time zones are kind of a human construct, in a
Yeah.
way. They're designed to bring order to our experience of time, across a rotating globe.
That is fascinating. Speaking of time zones, my notes mention something interesting about South Africa. It says that because of its geographic location, South Africa could have two time zones.
That's right. The lines of longitude at both 15 degrees east and 30 degrees east. They both run right through South Africa. What that means is, geographically, part of the country naturally aligns with the time zone. 2 hours ahead of Greenwich Mean Time, GMT2, while another section aligns with the time zone 1 hour ahead of GMT. So GMT1,
So why doesn't South Africa have two time zones then?
well, practically speaking, having two time zones within a single country can make things very complicated. For communication, transportation, just daily life in general, imagine the confusion of scheduling a meeting or catching a train, even
Okay.
just calling someone across the country if different parts of South Africa were on different time zones.
Yeah, I can see how that would get messy, for sure. So to keep things simple, all of South Africa operates on South African Standard Time, which is GMT2.
Exactly. It's about finding that balance, you see,
Uh-huh.
between being geographically accurate and just practical convenience.
Okay, so we've covered how the Earth's rotation affects our perception of time and how we've created these like systems of time zones to, manage it. But there's another thing about Earth's movements that shapes our lives. It's about its tilt. My notes mention that the Earth's tilt is what actually causes the seasons.
You got it. It's not just about the Earth spinning on its axis, it's also about the angle at which it spins too. The Earth is tilted on its axis at about 23.5 degrees, and that tilt, combined with our planet's orbit around the sun, that's what gives us spring, summer, autumn, and winter.
Okay, so I'm picturing the Earth like a spinning top, kind of. One that's like a bit off kilter as it goes around the sun. So how does that tilt actually cause the seasons?
Okay, imagine this. As the Earth orbits the sun, this tilt means that different parts of the planet receive different amounts of sunlight, throughout a year. When the northern hemisphere is tilted towards the sun, it experiences summer because it's receiving more direct sunlight and for longer. So it's experiencing longer days at that time. At the same time, the southern hemisphere is tilted away from the sun. So down there, they're experiencing winter with shorter days and less direct sunlight.
So when it's summer in the northern hemisphere, it's winter in the southern hemisphere, all thanks to this tilt.
Exactly. Then, as the Earth keeps orbiting, the seasons gradually change too. There are 2 points during the year when the Earth's axis is tilted neither towards nor away from the sun, and those points in time are called the equinoxes. During the equinoxes, so around March 21st and September 23rd, day and night are roughly equal in length all over the world.
Ah, so the equinoxes are like these, I don't know, points of balance maybe, between the extremes of summer and winter.
That's a great way to think about it. And the solstices, they occur around June 21st and December 21st. They mark the points when the Earth's tilt is at its maximum, towards or away from the sun. Those are when we experience the longest and shortest days of the year.
Okay, that makes sense. And it's interesting to think about all the different cultures and how they've like marked these astronomical events, throughout history.
It really is. The solstices and equinoxes have always been so culturally significant. And for agriculture, too, for civilizations all around the world. Many ancient cultures even build monuments to track these events, like Stonehenge in England. It aligns with the solstices.
It's incredible how these natural cycles have been observed and celebrated for centuries, really. It connects us to the past. But let's shift gears a bit. We're jumping from ancient wonders to modern marvels, specifically satellite images. It still kind of blows my mind that we can even see our planet from space.
It really is remarkable,
Yeah.
especially how far technology has come. It's given us this incredible new perspective on our planet. And it's important to remember, these images aren't just static pictures. They provide tons of information about Earth's systems, too.
Yeah, my notes mention using them for weather forecasting, tracking deforestation even. You can even identify natural resources from space, right?
Absolutely. Satellites these days are equipped with really advanced sensors. They can collect data on a huge range of things, from cloud formations and ocean currents
Hmm.
to changes in vegetation and even urban sprawl.
It's incredible to think about all the ways we're using satellite imagery to understand and manage our planet better. It's like having a God's eye view of Earth. It lets us see things we could never observe from down here on the ground. It really makes you think about how everything is like connected on Earth, right? Like
Yep.
from how the Earth spins to the seasons, and then how technology lets us see all these patterns from, a whole new perspective.
Exactly. And we can't forget those maps we were talking about at the beginning. They might seem simple, just like basic tools and stuff, but they're really not. They actually represent like a really complicated mix of science and mathematics, and even just like human perception.
True. It's honestly kind of amazing how much we've covered. Just from these geography notes, it's like a whole new world opened up to me from like how map scales and projections change how we see the Earth to like thinking about those crazy movements of our planet.
Mhm.
The ones that give us day and night and time zones and even the seasons.
Right, and we can't forget about satellite imagery either.
Hmm.
Just, wow, the fact that we can actually monitor the planet's health from space, track weather patterns, even look back in time to, see how the Earth has actually changed over, like, thousands of years.
It just shows that even though we've learned so much about Earth already, there's always going to be more to discover, more connections to make for sure, and more to learn about, how we fit into this crazy ever-changing planet.
Speaking of discoveries, and
Yeah.
as you keep going in your geography journey and beyond, I have a question for you to think about. How do you think maps will change in the future? And they've changed so much already with virtual reality and augmented reality and all that. Could we like navigate 3D maps one day?
Hmm.
Maps that like blend in with everything around us? Or maybe we'll even interact with like geographical data in ways we can't even imagine yet.
Now, that is a fascinating question. It really makes you realize that our journey of, exploration and understanding is definitely not over yet. Thanks for joining us today on this deep dive into the world of maps and globes and basically all things geography. Until next time, keep exploring.